Hello, Assalamu alaikum, and welcome. Today we're going to build a real-world Java EE web application, a system called Ajax Cut, Campus Barber Booking System. In this project, we'll be using a few powerful technologies. First, we'll secure the system using JSecurity Check, a built-in security mechanism in Tomcat that handles user login and role-based access control without writing any custom Java code for authentication. Next, we'll use Jakarta Server Pages, or JSP, to create dynamic web pages. These pages will allow students to book appointments and admins to manage bookings, all with real-time interaction. Finally, we'll use JDBC, the Java Database Connectivity API, to connect our application to a Microsoft SQL Server database. Through JDBC, we'll insert, retrieve, and update booking records as users interact with the system. By combining these technologies, we'll build a secure, scalable, and functional web application that mirrors how real-world systems work. From login to data management, let's get started. Now, let's begin by creating the login page. We'll create a file called login.jsp inside the web content folder. This page uses a simple HTML form. The form's action is set to JSecurityCheck, which tells Tomcat that this form will be handled by its built-in security system, Toddy, not by a custom servlet. Inside the form, we add two input fields. The first is for the username, and it must have the name J_username. The second is for the password, and it must have the name J_password. Finally, we add a login button to submit the form. When the user clicks login, Tomcat will automatically handle the authentication process behind the scenes based on the user information we provide in the server configuration. The login page remains simple. No need to write any Java code for authentication. All the heavy lifting will be done by the server. In most modern Java web applications, security is a top priority, but writing custom login code from scratch can be complex and error prone, especially for beginners. That's why Java EE gives us a built in solution, container managed security, and it's configured using a file called web.xml. The web.xml file is like the instruction manual for the server. It tells Tomcat what to protect, who can access what, and how users should log in. Instead of writing login logic in Java, we use something called JSecurityCheck. Here's how it works. The login form sends the username and password to a special URL, JSecurityCheck. Tomcat then checks those credentials against a predefined list of users, usually found in Tomcat users.xml. Once authenticated, the server automatically creates a secure session and gives the user access based on their role, like student or admin. These roles are declared in web.xml2. You can also specify which pages are protected using comma and define what happens when login fails, like redirecting to a custom error.jsp. So to summarize, with just a few lines in web.xml, we can set up a secure login system, manage user roles, and restrict access, all without writing a single line of authentication code. Next, we configure the security settings inside the web.xml file. The web.xml file is located inside the WEBINF folder. It controls how our web application behaves. First, we define security constraints. We protect an important page, admin panel.jsp for admins. Under the security constraint section, we define that admin panel JSP can only be accessed by users with the role admin. Next, We configure the login method. We use form-based authentication by setting the auth method to form. We specify the login page as login.jsp and the error page as error.jsp. Finally, we declare the two roles, admin and student, using security role tags. This entire configuration ensures that only logged-in users with the correct role can access the pages they are authorized to use. Now we move on to configuring the users and roles inside Tomcat itself. We do this by editing the Tomcat users.xml file. This file is located inside the Tomcat conf folder. First, we define two roles, admin and student, using the role tags. Then we create two user accounts. The first user is an admin account. For example, the username is admin_cecs and the password is secure123. This user is assigned the role of admin. The second user is a student account. For example, the username is lect1 and the password is pass123. This user is assigned the role of student. By defining users and roles here, we enable Tomcat to check user credentials when they log in through the system. If the credentials match and the user has the correct role, Tomcat will allow access to the protected pages. If the credentials are wrong, the user will be redirected to the error page. And with that, our authentication and authorization system is fully configured. Now we're going to start building the student booking page. The front-facing form where students can submit an appointment request to Ajax Cut. This page is called booking.jsp and it's going to live inside the web content folder of our Eclipse project. Let's create a new file now. Right-click on web content, choose new greater than JSP file, and name it booking.jsp. Click Finish. The purpose of this page is to collect input from the student, like their student ID, the barber they want to choose, the type of service, the date, and the time. Once the form is submitted, the data will be sent to a servlet, the booking servlet.java, which will connect later. Let's begin typing the structure of the page. We start with the basic HTML layout, the opening tag, the closing tag, and the tags. Inside the section, we can give the page a simple title, something like Book Appointment, Ajax Cut. Now, inside the we'll add a heading at the top of the page, just a line that says Student Booking Form. Below the heading, we'll create an element. We set the action attribute to Book Appointment because that's the URL we mapped in our web.xml file to the booking servlet. The method will be POST since we're submitting data securely. Now we add the form fields one by one. First, an input for the student ID. This will be a text field and we'll use the name attribute as a student ID. Next, we need a drop-down list for the barber name. We use the tag with options like Ajek, Kimi, and Din. Each barber has a value and a label. After that, another drop-down for the service type, haircut, fade, beard, trim. Then we'll add input fields for the date and time of the appointment. For these, we use type equals date and type equals time, respectively. And finally, a submit button with the label Book Now. Let's review the full form. It's simple, clean, and ready to send data to our backend. At this point, you can save the file and run it inside your browser. You'll see a fully working form, and in the next step, we'll build the servlet that receives the booking request and stores it into the database. Let's move on. Before we start coding the booking servlet, it's important to design the database table where we will store the booking information. Let's create a table called Bookings in our Microsoft SQL Server database. This table will have several columns to capture all the important details of each appointment. First, we'll create an ID column. This will be the primary key for the table. It will be an integer that automatically increases for every new booking. Next, we'll add a student.id column. This will store the ID of the student who made the booking. Then we'll add a barber name column to record which barber the student has chosen. We also need a service type column to store the type of service the student selected. Then whether it's a haircut, a fade, or a beard trim. To schedule the appointment, we'll add an appointment date column for the date and an appointment time column for the specific time. Finally, we'll create a status column. This column will track whether the booking is still pending, approved, or declined. In this project, the booking.jsp page is used only to collect input from the student. It provides the user interface, a clean and simple form where the student enters their ID, selects a barber and service, chooses a date and time, and clicks the Book Now button. But this page does not actually process or save the data. Instead, the form sends all the input to a separate component, a Java servlet, using the POST method. The form's action points to a path called Book Appointment, which is mapped in the web.xml file to a class named bookingservlet.java. The servlet acts as the controller. It receives the form data using request parameters, checks if everything is valid, connects to the SQL Server database through JDBC, and then inserts the booking into the database. Once the operation is complete, the servlet redirects the user to a confirmation page or an error page if something goes wrong. We use a servlet to process the data instead of handling it directly in the JSP because servlets are better suited for business logic. They help us keep the responsibilities separate. The JSP focuses on displaying the interface, the view, while the servlet focuses on processing, validation, and database interaction, the controller. This approach keeps our code organized, more secure, and easier to maintain as the project grows. It also follows the model view controller design pattern, which is a widely accepted best practice in web development. In this part of the system, we're going to take a closer look at the booking servlet.java file. The servlet that receives booking data from the form and saves it into the database. This servlet is the middle layer between the user interface and the database. When a student fills in the booking form and clicks submit, all the input is sent to this servlet through an HTTP post request. The servlet receives the data using the request get parameter method. It collects information like the student ID, the selected barber, the type of service, and the chosen date and time. Once the data is captured, the servlet performs a basic validation check. It makes sure none of the required fields are empty. If a field is missing, the servlet redirects the user back to the form and includes a simple error message. This helps prevent empty or invalid records from being stored in the database. If the input is valid, the next step is to connect to the database. The servlet calls the dbconnection.getConnection method, which opens a connection to our SQL Server database using JDBC and the JTDS driver. Next, we prepare SQL insert statement. We use a prepared statement object, which is a safe and secure way to insert data without exposing the system to SQL injection attacks. Each form input is inserted into the query as a parameter using PSSetString. Once the statement is ready, we execute it using PS execute update. This tells the database to save the booking into the bookings table. When the insertion is successful, we close the connection and redirect the user to a confirmation page, letting them know that their booking has been received and is currently marked as pending. If anything goes wrong during this process, like a database error or connection failure, the servlet catches the exception, prints the stack trace for debugging, and redirects the user to an error page. This servlet is an essential part of the system because it handles the actual logic of storing bookings. It separates the business logic from the presentation layer, which keeps our application clean and maintainable. Because our project connects to Microsoft SQL Server, we must make sure the JDBC driver, the jtds-1.31.jar file, is available to the server. To do this, go to your Tomcat installation folder, open the lib directory, and copy the jtds.jar file into this folder. This makes the driver available to all web apps running on that Tomcat instance. If you skip this step, the system might work inside Eclipse, but it will fail to connect to the database once deployed. Now, start your Tomcat server. Once it starts, open your browser, go to your URL app. You should see your application running. You can test the booking form and log in as admin using the credentials you defined in Tomcat users.xml. At the very top of the file, we define the page settings for our JSP. The language is set to Java, and the page uses UTF-8 encoding, which means it supports all text characters properly. Right after that, we import all the classes from java.sql.*. This gives us access to important classes like connection, statement, and result set, which we will need to work with the database. Next, we start the HTML structure of the page. Inside we set the page title to Ajax Cut Admin. This title will appear on the Browser tab when the admin is viewing the dashboard. Inside we add a heading using. The heading says Pending Bookings to tell the admin what this page is about, managing student booking requests that are still waiting for approval. Now we open a block of Java code inside our JSP page. This is where we connect to the database and retrieve booking data. We declare 3 important variables: connection con to connect to the database, statement stmt to run SQL queries, result set rs to store the results from the query. At the beginning, we set all of them to null. Inside the try block, we attempt to connect to the database. First, we define 3 connection details: the URL, which tells the system where the database is located; the username, here it's SA, which is the default admin account for SQL Server; the password, the correct password for the SQL Server connection. Then we load the JDBC driver with class dot for name dot. This is needed to talk to the database. After that, we use driver manager.get connection to actually open the connection. If the connection is successful, we move on to the next step. Now, we create a SQL statement to run a query. Select from bookings where status, pending or status is null. This means select all bookings where the status is pending, or where the status is empty, or where the status is null. This ensures the admin sees every booking that still needs action. We execute the query and store the results in RS, the result set. Next, we build a HTML table. We define the column headers, ID, student ID, barber, service, date, time, action. This prepares the structure where we will display each booking record. Now, we start a while loop. RS dot next moves the pointer to the next booking record. Inside the loop, for each booking, we create a new row. We fill each column with booking details like ID, student ID, barber name, service type, appointment date, and time. This displays one booking per row. In the last column, we add two buttons, approve and decline. Each button is inside a small HTML form. When the admin clicks one of these buttons, the form sends the booking ID and the action, approve or decline, to the admin servlet.java. The servlet will then update the booking status in the database. After all bookings are displayed, we close the table. If there is any error, for example, if the database connection fails, the system will catch the error and print a simple error message on the page. No matter what happens, whether successful or error, we always close the result set, the statement, and the connection. This is important to free up resources and avoid database problems. Finally, we close the HTML body and HTML page. This completes the admin panel.jsp page, a simple, clean page that connects to the database, shows pending bookings, and lets the admin approve or decline with a click. Inside each booking row, we have two separate forms, one for approving and one for declining the booking. Let's look carefully at the first form. The first form's action points to admin action, and it sends the booking ID hidden inside the form. The submit button is labeled approve. When the admin clicks this button, the form sends the booking ID to the admin servlet, which will update the booking status to approved. Next, we have the second form. The second form's action points to decline booking. Again, we include a hidden input field to pass the booking ID, but this time the submit button simply says decline. When the admin clicks decline, the booking ID will be sent to another servlet, specifically the decline servlet, which we will now look at. At the top of the decline servlet.java file, we define the package name and import all the necessary classes. This includes standard Java SQL classes and Jakarta servlet libraries needed for web application functionality. Next, we use the @web_servlet annotation. This registers the decline servlet with the server and maps it to the URL pattern /decline booking. This is why the second form's action matches exactly, so the server knows where to send the decline request. Now we arrive at the heart of the request of the decline servlet, the doPost method. First, we get the booking ID from the request parameters sent from the decline button form. Then, we declare two important database objects: a connection to connect to the SQL Server database, and a prepared statement to safely send SQL commands. Inside the try block, we pass the booking ID from a string into an integer. We then prepare our database connection. Here, we set the connection URL, the username, and the password for SQL Server. We load the JDBC driver and open a connection using drivermanager.getConnection. Now we prepare a SQL update command. This SQL statement says update bookings, set status, nizam, declined, where ID equals ? This means find the booking with the matching ID and update its status to declined. We set the ID into the SQL command safely using ps set integer 1, ID. Then we execute the update. Once the update is successful, we immediately redirect the admin back to adminpanel.jsp so they can see the refreshed list of pending bookings. If anything goes wrong, like a database error, the catch block will print a simple error message and redirect the user to an error page. Finally, in the finally block, we make sure that both the prepared statement and connection are closed properly to avoid any resource leaks. Let's walk through the admin servlet.java file line by line. At the very top, we declare the package name ict.pmu.edu. This tells Java that this servlet belongs to the edu folder inside PMU under the ICT package. It helps organize the project structure. Next, we import all the necessary classes from Jakarta Servlet and Java SQL. These imports allow us to receive and respond to HTTP requests, connect to the SQL Server database, and safely execute SQL queries. Now we move to the class declaration. This servlet is named admin servlet, and it extends HTTP servlet. That means it can handle HTTP requests, like when an admin clicks a button on the admin panel. Just above the class, we use the @web_servlet annotation. This registers the servlet with Tomcat and maps it to the URL pattern /admin action. That's why in our HTML form inside adminpanel.jsp, we set the action to admin action. Next, we see a default constructor. In this project, we're not using it for anything specific, but it's included automatically by the IDE. Now let's move to the doGet method. Right now, it just returns a basic message saying serve that with the app path. We don't use this method in our current system. We focus on post requests. Now we come to the most important part, the doPost method. This is triggered when the admin clicks the approve button in the admin panel. First, we get the booking ID from the request parameter using string ID param request get parameter ID. Next, we declare our two database related objects, a connection to open communication with the database, and a prepared statement to safely send SQL commands. Inside the try block, we pass the booking ID into an integer. Then we prepare our database connection by defining the JDBC URL, username, and password. We load the JDBC driver using class.for name, and then use driver manager.getConnection to open the connection to the database. Now comes the SQL update. We write a query to set the status of the selected booking to approved, using a where clause to match the booking ID. We use prepared statement to insert the ID into the SQL query securely. And then we execute the update using execute update. Once the booking is approved, we immediately redirect the admin back to the admin panel using response send redirect admin panel JSP. If any error occurs, like a connection failure, the catch block prints the error to the console and sends the user to the error page. Finally, we close the database resources inside the finally block to make sure we don't leave any open connections. And that completes the logic inside admin servlet.java. This servlet is now fully capable of accepting a booking and updating the database, and it does so securely, efficiently, and cleanly. Thanks for following along. In this project, we've built a complete login secured web application using Java EE technologies. We learned how to use JSecurity check for secure login, JSP to build the front-end pages, and Servlets plus JDBC to process form data and connect to a SQL Server database, we created two roles, admin and student, and built a simple workflow where students can book appointments, admins can view and manage those bookings with just one click.